Hi there. In this video we're going to be talking about what to do when we're trying to convert a decimal like this to a fraction. And the decimal like this meaning what happens if we have some sort of non-repeating decimal and then after it the decimal is repeating. So this one of course is going to look like 0.23333333333 forever and ever and ever and ever. So our goal is to figure out how to put that into a fraction where our p over q are both integers. And integers, remember, are whole numbers. So we want it to be like 1 over 3, 2 over 3, etc., etc. So it's going to be complicated. In order to do this, what I want is to convert this into two different decimals, one being a normal decimal that we know what to do with, that isn't repeating, and then our repeating decimal after that. So in order to do that, I'm going to split this up. 0.23333 I know is the same as, so I'll put equal, 0.2 plus 0.03 repeating. And if you're having trouble with that, look back. Okay, and that should check out if we wanted to, add those together, 0.0333 forever and ever and ever. We would put our zeros there, add up each column, and great, this checks out, this works. So initially that might take a little bit of practice, but hopefully doing two examples will help. So we broke it up into two different decimals, and then individually we're going to break the first one. We're not going to break it, we're going to just convert it into a fraction. That's the same thing as 2/10, just knowing that this is the 10th place, after that is the 100th place, etc., etc. And then for this one, we're going to do something sneaky. We're going to add something and subtract something in order to make it so that this becomes a repeating decimal that we know what to do with, because in theory you know what to do with 0.33333 dot dot dot. That's a little bit simpler, but we'll go over that in this step as well if you need some refresher. So our goal is to try to figure this out so that it is a repeating decimal. Well, to get 0.033333, I want to turn this first number into a 3. If I can turn that first number into a 3, that means that I will get 0.333 repeating. Dot, 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 dot. That goes on forever. So what I'm going to do is just add 0.3. So I'm going to add 0.3, but I can't just add stuff to numbers willy-nilly. I have to also subtract 0.3 to make sure I'm not actually changing this number here. Instead, I'm actually adding a tricky form of 0, since 0.3 minus 0.3 is 0. And I can add to 0 to anything I want. It doesn't really matter. 0 is nothing. But it's going to help me break this problem up. So I'm adding 0.3 and subtracting 0.3. What's nice is I can add the 0.3 to this guy and subtract the 0.3 from this guy. I don't know why I'm calling them guys. They could be gals as well. So I'm going to subtract my 0.3. So this works because addition is commutative. You can rearrange everything when you're doing addition. And of course, subtraction is just a version of addition. It's just addition of negative numbers. Okay. So now that I've moved these around, let me finish moving them around. 0.03 plus 0.3. Now I'm going to combine both of these. And in order to combine both of these, I'm actually going to convert this into a fraction. And make sure you rewrite everything. That's really important. when you're doing arithmetic and algebra. Minus 3.3 is minus 3/10. That should be easy to figure out. 2/10 minus 3/10. We're going to keep the denominator the same. 2 minus 3 is -1. -1/10. In here, we have plus 0.333, or I can even just call it like that, which is equivalent to 0.3 bar. Okay, now we're getting somewhere. I'm going to scroll down. And now we just have to convert this to a fraction and add two fractions up. So to review how to convert this type of repeating decimal to a fraction, we pretend that this bar isn't here. So I'll do that with another color. Let's pretend this bar isn't here. And that means that that would be 3/10. But actually the bar is there, so we can't just get rid of it. In order to account for the bar being there, we're going to subtract 1 from our denominator. And so we have -1/10 plus 3 over 10 minus 1, and -1/10 plus 3/9. And that should check out to you, because 3/9 is the same as 1/3. You've probably memorized that 1/3 is the same as 0.333333333 forever. So that's good that that checks out with our intuition. And now all we have to do is add fractions. To do that, we're going to find a common denominator. I think if I just multiply this by 9 over 9, I will get 9 over 90, -9 over 90. And then I'll do this by 10 over 10, because I want to get ultimately this bottom number to be the same as this bottom number. And my goal is to be 90. And so I multiplied the 9 by 10. I have to multiply, I'll show that really quickly, just in case you're curious. The dots, of course, are another way to write multiplication. I multiplied by 9 over 9. When you multiply fractions, you multiply across. Okay, so 3 times 10 is 30. So now we have -9 over 90 plus 30 over 90. Another way to think of that is to switch these around, since addition is commutative. 30 over 90 minus 9 over 90. And that's always going to have 90 at the bottom, because that's how addition works for fractions when we have a common denominator. 30 minus 9 is 21. All right, so now let's see if this fraction, and of course we could reduce it by dividing by 3 on the top and the bottoms. That's the same as 7 over 30ths, 7/30, 7 over 30. Let's check if 7 over 30, 7 divided by 30, 0.2333333 forever. Woo! So exciting. Okay, hopefully that made sense to you. If not, leave a comment, or if you did it in a different way, leave a comment, because this is not the only way to do this. This is just the most intuitive way for me to do this. There's probably some tips and tricks you can do to make this a little bit easier. Okay, now let's do this harder one. We're going to apply some of the same techniques, but it is definitely a level plus, a level more difficult. So let us split this one up into 0.921 plus 0.000, those are zeros, not sixes, 7, 2 repeating. Of course, this is going to look like 9, 2, 1, 7, 2, 7, 2, 7, 2, 7, 2, 7, 2, 7, 2, etc., etc., etc. Okay, now, and I'll put this equal here. So now what I want to do is I want to get this number to be 7272 repeating. The problem I'm seeing right away is if I just add, let's say I just add 0.72, and then I have to subtract 0.72 later since I just want to add 0. Then I'm going to end up getting 0.72072 repeating. And so this 0 is not good. So I had to think about it a little bit, and hopefully you've had a little bit of a chance to think about what you might do in this situation. But instead of adding 0.72 or 0.072, which also won't work, what I'm going to do is actually add a 0.272. And this is a little bit difficult to think about, but of course I have to subtract the same thing. The reason why it's difficult is this number is going to end up being 0.27272. And so that goes on forever, 72727272727272. So if you think about it, there's really no end to that number. We don't know if that number, in theory, ends on a 2 or ends on a 7 because it never ends. So saying that is actually the same thing as saying 2727272727. Think about that, and we're going to check to see if this is right at the end. Maybe my way is wrong. Maybe there's another way to think about it. But I have a hunch this is going to work. So now I need to do 0.921, and I'm going to do it on my calculator because it's a lot of calculations. 0.921 minus 0.272, so it's 0.649. Okay. And now I'm going to change this to a fraction, 649 out of 1,000, since we're in the thousandths place. This one is 0.27272727 plus 27 over 100 minus 1. Since first I ignore the bar and then I add the bar back in by subtracting 1 on the denominator. So now I'm left with 649 over 1,000 plus 27 over 99. This is a difficult fraction to do. Some calculators will do it for you automatically. Mine, unfortunately, is the bad computer calculator. So what I'm going to do is do the hard thing and multiply by 1,000 over 1,000 on the right, multiply by 99 over 99 on the left. So 649 times 99 is 64,251 over 99,000. 99 times 1,000, 99,000, plus 27,000 over 99,000. And so all I have to do is add 27,000 to my answer from before, and I get 91,251 divided by 99,000. I hope this is right. If it's wrong, I'm going to be sad. Ooh, I think that looks right. Yes, 9217272727272. It works. Let me know if you have any questions in the comments, and also let me know if you did it a different way, because I'm curious how other people think about this problem. Again, this is just the most intuitive way I know, that I just thought of when I was thinking about these problems, and I know there's probably other ways, and other ways to prove that this is true as well, why this method works. So, have a good one.